Welcome. In this video, we're going to continue to use secant lines to estimate average rate of change. Then we're going to use some secant lines adjacent to a particular time in order to estimate the instantaneous rate of change. So a tank holds 1,000 gallons of water, and this water is draining from the bottom of the tank over a half-hour period. The values in the table below show the volume of the water remaining in the tank in gallons after t minutes. So at 5 minutes, this is how many gallons were in the tank. 25 minutes is how many gallons were in the tank. And by 30 minutes, you can see the tank is empty. Let P be the point 20, 111. So that is at 20 minutes, there was 111 gallons left, and that's here at this table. So this is our point P. Let's find the slope of the secant lines PQ, where Q is the point on the table, with t equals 5, 10, 15, 25, and 30. So that is, we're going to let Q equal 5 different time values to estimate our secant lines. So let me write P a little neater here, because P is unchanging. P will never change. But for our first example, we're going to let Q be the point starting at 5 minutes, and that's 694 gallons. So this is our first Q. And now to compute the average rate of change, that is the gallons lost per minute, we first have to compute the difference in the gallons, so the change in number of gallons in the tank, and divide that by the change in time in minutes. And this gives us about negative 38.87 gallons per minute. All right, so let's try this for a different Q. So now, instead of Q equaling the 5-minute mark, Q is the point beginning at the 10-minute mark. So let's change our Q. Now Q is 10, 444. So at the 10-minute mark, there are 444 gallons remaining. And let's do this again. So we end up with negative 33.3 gallons per minute. That tells me that between 10 minutes and 20 minutes, the average water loss for the tank was about 33 gallons per minute. So now let's do this again, and this time Q is going to be 15. So I think you're seeing the idea here. So now Q is 15, 250, and then we're going to let Q be 25, 28, and then finally, let's see if I can squeeze one more in here. And then the final point we're going to let PQ is the 30-minute mark when there was no water left in the tank. So please pause the video and try to estimate the average rate of water loss during these time periods. So that is between 15 minutes and 20 minutes, between 20 minutes and 25 minutes, and between 20 minutes and 30 minutes. All right, so you should have gotten these values for the 15-minute mark, the 25, and the 30-minute mark. That is the average rate of water loss between 15 and 20 minutes within this tank was about 27.8 gallons per minute. And I'd say it was a water loss, so that's kind of taking this negative into account already. Between 20 minutes and 25 minutes, there was about 16 gallons lost per minute. And between 20 minutes and 30 minutes, the water loss was 11.1 gallons per minute. So again, we're interested in now estimating the slope of the tangent line at P. So when we're finding the slope of the tangent line, what we're actually doing is estimating the rate the water is draining at the 20-minute mark. And we're going to do that again by averaging adjacent secant lines. So the secant line at the 15 and 20-minute mark and the secant line at between the 20 and 25-minute mark, these are the two slopes we're interested in. So these are the adjacent secant lines, or the adjacent slopes of the secant lines. That is the average water loss between 15 minutes and 20 minutes and 20 minutes and 25 minutes. And we're going to use these two values to estimate the rate of water loss at exactly the 20-minute watermark. So we'll do this by adding negative 27.8 plus negative 16.6 and dividing that by 2. So at the 20-minute mark, the water was draining from the tank at a rate of 22 gallons per minute. I hope this video was helpful.